Hi, and welcome to today's live stream. We call this AWS Data Lake Out of the Box. This is a topic that's very interesting for me because I'm coming from the streaming area, so I'm not very deep into data lakes, into data warehouses, and so on. And luckily today I have two very interesting people who know their way in and out of with this topic, help clients. It's Kristine and Arber Bushati, sorry. And yeah, let's bring them in and then talk a bit about the agenda.
Hi there.
Hi,
Hey.
hi Arber, hi Kristine. Hello everybody in the chat. Let me know if the chat works. Just post a quick hello world in the chat on YouTube and on LinkedIn. I think it works. So let's quickly get into the agenda, what we're going to talk about today. So our agenda today is first, Arber and Kristine are going to do a quick introduction about themselves and about Kreuzwerker. And then we're going to look into cloud, into data lake and data warehouses, which is, as I said, a super important topic. And then we're going to look into why analytics platforms backed by data lakes, because that's the new thing. That's the thing everybody is talking about. Everybody is struggling with, and is a big deal to set up data lakes, data warehouses, lake houses, Then Arber is going to show us a electric scooter use case for a analytics platform. And we're going to talk a bit about their analytics platform, basically out of the box toolkit, how you can set this up very easily. So quick check. Yes, it works on YouTube. Hi, Greg. Hello, hello. Hey guys here. Hi. My wife is also here. All right. So, Kristine, Arber, please, a few words about you and what you're working on right now.
Sure. I think I would start. So hi there, my name is Arber. In Albanian, it's pronounced Arber, just to confuse the audience a little more. I'm a consultant at Kreuzwerker. I'm focusing on data engineering, especially in the cloud and especially in the AWS ecosystem. And I live near Frankfurt. And not too long ago, I did my Master's of Science in Business Information Systems at the Technical University of Darmstadt, where I did actually focus on domains such as machine learning, communication systems, and cybersecurity. Besides that, I did backend development, mainly in Java. And now what brought me actually to data engineering, that's interesting, was probably the connection on the one side of working with data within machine learning projects and trying to generate business value. And on the other side, incorporating software engineering best practices, which I was confronted during backend development. And I'm a huge fan of this conjunction. So this conjunction of working with data, on the one side, also keeping software engineering principles in mind. And over time, I became very interested in topics around building robust data architectures in the cloud. And that obviously includes data pipelines. It includes data modeling. It also includes automating stuff such as setting up CI/CD pipelines and so on. So that's about me.
Oh, so a lot the data engineer way, right? Coming from software engineering, data.
Sure.
Yeah. Kristine,
Yeah, hi.
CTO.
Yeah. Happy to be here. Yeah, hi. So my name is Kristine. I'm currently CTO at Kreuzwerker. I've been working in the IT industry, I think, for about 15 years by now in all different kinds of areas. So from like QA to software engineering to ops stuff, and not so much in data actually. But yeah, of course, data is a super important topic, getting more and more traction and more important in all areas. I think there's no area that's not touched by it, which makes it very important. And maybe a couple of words about Kreuzwerker. Kreuzwerker, we are a consultancy. We help and support clients in all areas of the cloud transformation journey. So from migrating them to the cloud, designing, implementing cloud native solutions, running those solutions for them, and of course, also advice in the area of data. And cloud for us means AWS. Ava already mentioned it. So we have been AWS partner for almost 10 years now. And that's why we're here today to speak about data in AWS on AWS. So yeah, thanks for having us.
Super cool. Thanks. Yeah, AWS is also, it's also my favorite. I think it's not really a secret. So cool. Thanks for the introduction. But I want to mention one thing. Everybody in the chat, if you have questions, put them in the chat. Either Arber and Kristine can also read them. So if there's something that fits very well in, then most likely we're going to answer them straight away. Otherwise, we have a Q&A section at the end where we are taking your questions. Yeah, so as said in the agenda, let's talk a bit about data warehouse, data lake, something that I'm very interested in.
Yes. So before we talk about any of these architectures, I want to point out that none of them is the answer for everything. So there's no single size fits all solution. That has to be clear. So every data architecture that you choose has its pros and cons, and you will always have to consider the trade-offs. So even though data lakes are very, very flexible, flexibility also has its own price, and that's important to know when deciding what architecture, what your architecture should look like, so to say. And let's say that before there were data warehouses, actually, reporting and analytics were mainly done on operational systems. And at that time, before the 80s, so to say, those were mainly relational databases, as these stored transactional data, such as, for example, financial transactions or supplier orders. And as you know, such relational databases can be MySQL or PostgreSQL and so on. And actually, it is still quite common practice to use relational databases to not only collect and store your data, but also to create financial reports or perform different kinds of descriptive analytics. As I said, you can perform analytics on these OLTP systems. That's how they are called, on these database management systems such as MySQL or PostgreSQL, because under the hood, you query your data using SQL, and SQL is quite flexible. However, analytics on these systems only work well to a certain degree, and it can actually have an impact on your production database. For example, depending on the analytical workload. So if your queries could impact the performance of your production databases, your OLTP systems. And another key problem was, or is, that companies typically have different databases for different business units. So performing analysis on the data that is so fragmented and distributed over different systems was quite complex and time-consuming. So,
that's the standard where we hear about data silos, right? That's where you have your individual projects. Nobody talks to each other, and now create a report. Good luck.
True. So this is also actually where this new trend emerged. This trend of using a separate system, an analytical oriented system, which should then be used for data analysis. And those systems were actually called data warehouses. So a data warehouse essentially is a central repository for data from various resources, those relational databases, for example, that store your transactional data. And a data warehouse has the main purpose of generating regular reports and also enable analysts to perform specific types of analysis on large data sets. And what is now awesome is that we have this separation between OLTP and OLAP activities across systems. And this was and is still essential because on the one side, as I mentioned, we now do relieve our production databases as we are performing our complex analytics on a separate system. And on the other side, the query engine of our data warehouse can be optimized for analytical operations instead of transactions. And so analysis can be performed more efficiently. And also important decisions for the business can also be made much faster, so to say. So that's quite important to know about a data warehouse, so to say.
What do you see from your clients' perspectives? Are they usually at the step where they already have a warehouse and want to now take that next step to the cloud, to a data lake, or are they starting very often from zero, where they have just their transactional stuff and want to get some analytics?
Sure. Actually, it's a mix of everything. So we have clients, startups that have data, they don't know what to do with it. And they have this data stored across different databases, but they don't have a data warehouse or data lake. So they want to be consulted in what they should set up in order to basically generate insights, so to say. But we also have clients that already have set up Snowflake or Redshift instances and need help there. And we also have clients that have a mix of both, like a data lake and data warehouse setup, and that essentially need help in setting up these data pipelines or improving them and so on. So that's everything.
Yeah, because I don't know, Kristine, if you also see this out there. When I look at job descriptions for my students, and very often you see this analytical load. You don't see that somebody needs to, or somebody wants data engineers for their transactional pipelines. Usually that's very traditional. That's already done, or it seems like it. What's your impression on this?
But I think there's still a lot of clients out there that still have data warehousing. So and that actually also need to migrate them to the cloud. And I mean, and also, I mean, I think I read an article this day about the job description, the current job description of data engineer, that it often doesn't really contain what then the actual job is. So, I know actually it was about DevOps engineering, but it was like, this is the job ad where we want to be, but then in the end it's not. So I'm not sure how reliable these
that's true.
job ads actually are. And the thing, I mean, especially in the data, but there's also still a lot like you have to know everything in a. I think it's still in the data world a little bit like, okay, there are all these tools and you have to know all of them. And I kind of, it's a symptom to actually, we don't know exactly what we want to be doing. It's like we just know we want to be doing something.
Yeah. So I'm guessing that influences you as well, right? That you have to work with the clients to actually help them figure out what do they want. Right?
Yes.
Oh, yes.
And I mean, what do you actually want to do with the data, right? I mean, that's kind of the question always. And it's not about, I think in a lot of cases, yeah, of course you can set up a data lake. Yeah, of course you can put all your data in there. I mean, that's not the hard part, I would think, but really like, okay, what do you want to do with your data?
Yeah, because Arber, you mentioned this. You said, and I was immediately thinking about this when you said data lakes are very flexible, right? But like, if you don't know what to do, it just gets a pile of data and like what to do. Yeah, cool. So we're looking also today. We're looking into the analytics part, not into the transactional part, right? We're going to look into the data lake, into the data warehousing part. Which is very important right now. Yeah.
What do you think, Andreas, by the way, of data meshes?
Data mesh for me, it's very much marketing right now. Okay. So I'm not that convinced, because when I always look into the back end, then it's pretty standard. It's not really. I don't know. I would not have given it a name for it. Because like making data available, that should be the standard. Well, yeah, I can see that the use case for it is very important, and if that name and that initiative helps, that's very good. Why? What are you thinking, Kristine? I think
I'm not sure. I mean, I think for larger clients it makes sense. Like if you really have a big organization, you need all the governance. You really have different domains. Then it makes sense. But it's with also as Arber said, we sometimes have smaller startups, and I mean then then it's just over engineered and over. So I think as Arber said in the beginning, right? It always depends. There's no one.
But I think you're right. If it's let's say you have a startup, you need to be ready to implement this at some point, but you don't need to start with it, because most likely you have a single project, and that needs to be the huge win where you have your business with, or make your main business with, and then. But for larger companies, I'm remembering from the Bosch world where I'm coming from, it's like 1,000 projects with 1,000 different setups, and like. So there
yeah. But I think what always is really was part of this data machine is really the whole topic of governance, right? And I think this is, and security, and this is becoming, not just in data, like everywhere, this is becoming more and more important. And I think this, at least having this in mind, is very important, and getting more important.
That's very true. That's very true. Just giving everybody full access. It's dangerous.
And then it's also, we talk about moving to the cloud, right? I mean, that's also, I think there's a big mindset shift in that as well, because everyone has access to everything but it comes, what we see, like one big challenge of moving to the cloud, not just in data, but everywhere, is really to this mindset shift and adopting to the also different kinds of security privilege. And this is
I think I know what you mean, because it's very the cloud is very dangerous. It's very easy to give a lot of people access to it, like to the data, right?
So just put it all in S3.
You go. Put it all in, and you just have access. Just do something with it. That's not a good idea. How have you, I think we had that fits to the next agenda point, your cloud versus on-premise. So you do this for a longer time. So how do you see that transition from on-premise stuff to the cloud? What's your learning here from
the data perspective?
Yeah.
So I have to admit, I'm not that old to have actually really experienced this this shift from on-prem to cloud, so to say. There's still a lot of companies, especially in Germany, that are still operating on-prem, but there's a huge improvement compared to the last 2 decades, so to say. And maybe we can talk about why this shift from on-prem to cloud is important, because for example, with regards to data warehouses, one big limitation they have is that a large initial investment at the beginning is needed, especially for the hardware, so to say, because a data warehouse essentially is a big application that stores a lot of data that also needs that compute power, so to say. And there are still data warehouses where storage and compute capabilities are not separated, meaning that the core storage and computing capacity is located on the same physical hardware. That means that if you want to scale your storage, so if you want to add more storage capacity, you probably also have to add more compute capacity, even if you don't want to. This is vertical scaling. And as you know, storage is cheap, but compute is expensive. And this is actually not the case for modern cloud data warehouses such as Snowflake or BigQuery, because there you have this decoupling between storage and compute, which is quite attractive, because now for startups, for example, you don't need these initial investments, because you can pay as you want. You can pay as you go. You don't, especially for these data warehouses, you don't have to pay upfront, which is quite attractive compared to on-prem solutions. Yeah.
It's also, but also, like you mentioned, BigQuery is also on AWS. I think Athena is the prime example for this as well, right? Because with Redshift, you have to get some instances and let some instances run. But I think Athena is serverless, and that. What would you say?
Yes. So Athena is basically. Actually, those are two different type of systems. BigQuery is actually a data warehouse. So you can store data in that data warehouse in BigQuery, And you also have the capability to query your data natively in BigQuery using SQL. So that's supported. And Amazon Athena actually is just a serverless query engine. But you still have your data needs to reside somewhere. In that case, you can leave it in S3, which is your data lake, so to say. And then you can tell Athena to basically query your data, which resides in S3. So, but there again, that was actually good that you mentioned it. This combination of S3 and Athena is it's serverless, and B, you have this decoupling between compute and storage, because you can scale your S3 data lake as much as you want. And also Athena will scale independently from your storage capacity, which is nice.
And I mean, it's true serverless in a way, right? It's not like Redshift serverless, where in the end you just don't manage the servers, but conceptually it's still the same, right? So, I mean, I think true server is always you use the native cloud solutions, and they do, there's some magic, but you don't even have to think that they are somewhere servers. Whereas with, I think now Amazon also released Neptune serverless days, EMR server, like everything is serverless, but basically just means you don't have access to the physical machines, but conceptually it's exactly the same thing. Like,
that's true.
So I think Glue is the true serverless, like true in the original sense, solution from.
And because one thing, like Eka was asking here, not sure about low storage. She meant low cost here. The next comment, low cost storage compute for BigQuery. Like if you same thing with Redshift. If you store the data into your warehouse, this most likely is going to cost you a lot more than if you have that completely separated, right? That you use your data lake and you use the processing on different resources, right?
Yes. Even in sorry,
Go ahead.
if you want to say, okay, even in GCP, that might be true about BigQuery, but a common pattern that's actually quite popular is to, in GCP, for example, to store lots of your data in Google Cloud Storage, which is a object storage, and then use BigQuery to query the data which resides in your Google Cloud Storage. And the same is actually the case for AWS. You store your data in your data lake, which is S3, and you can then use either Athena or Redshift Spectrum serverless, the serverless variant, to query that data. In that case, you would profit from a cheap storage solution. So, yeah.
What I'm asking myself in this, isn't Redshift, like we often say Redshift isn't that good compared to BigQuery or something.
Why does Redshift have the bad rep in the data world?
Yeah, but actually, when you think about it, you want to create a analytics store, you want to set your warehouse on top of it, you get yourself Redshift, and then you have these two options. With Spectrum, you have the full capacity of querying data from the lake, or you store it directly in Redshift and have that integration, have that power. Right? So it's not that bad.
I think I read an article about it like a couple of months back about why Redshift has this really bad reputation. And sometimes I think it was because it was the first one.
True.
So sometimes I think it's the thing that I don't remember the details, but it was really because, I mean, in the beginning, stuff is not usually not good, right? I mean, they're usually like things wrong with it if something is new. And sometimes it's manifest then, like these initial problems there were manifest itself. It's not good. So
that could be.
I'm not sure if it's.
I think one other thing is when you, as a novice, when you start with it, you start with BigQuery. It's very easy. You start with Redshift, you have to configure a lot.
Yeah, but the general thing with AWS, to be honest, I mean, that's a thing, and this is, I mean, but that's, to be honest, I think that's in all the AWS product, it's the developer experience.
Yeah.
And generally, it's getting better, But I think historically, AWS did never have a strong focus on developer experience or like user experience in general. So it's with a lot of services where you have to click there. You have to, I mean, if you do it via the console, it's it's not smooth.
Yeah, but from a functionality wise, it's great.
Yeah.
So from what I have seen and what I have heard people use it for, it's like,
Yes,
I'm guessing that's also why we're talking about it now, because it's a good tool. And if you're on AWS, it's like, why would you use something else? If there
but the
is
getting
already
starting experience is often with AWS, I think, not the most nicest one. That I think this is also one of the reasons I think we built this data toolkit to really have like this initial hurdle of getting started, to make it easy in a way to have something. And once you have it something, I mean, then it's you can go from there.
And that most likely gets a bad rep also there. Yeah. So, but it's still simpler than when you think about on-premise, right?
Yeah, so, of course. It's simple. I think also you asked in the about what we see of clients moving to the cloud, and I think there's one. It depends for whom. To be honest, it depends for whom. I mean, in general, I would say it's simpler, but I think one thing we also see, because we also just briefly touched on the topic of cost, and I mean the cloud can be expensive if you use it wrong. So, and I think this is also something to be aware. And also, I think with the cloud adoption, I mean, in general, maybe not only about data, cost control shifts more. I mean, it gets decentralized more, right? It's like previously there was an IT department. They were managing the infrastructure. They bought new servers, and now it moves to the team. Like in large operations, it moves to the teams, or departments. They are responsible for the cost. They suddenly get access to the AWS bill. Like,
that's true. It can be problematic.
And it can get expensive if you don't set up like your billing alarm. If you don't set it up correctly, then you can get unpleasant surprises, right? And also because it's unlimited. I mean, at the end, like if you run an on-prem, at some point the disk was full. It was just full.
Yeah.
It's never full.
Yeah, but on-prem you had your resources and that was it. So you could not like query a lot of data with BigQuery and run into high costs, because what you had was what you had.
Exactly.
Right?
Yeah. So in terms of, I think, functionality, I mean, that's why you move to the cloud in a way. I think that's the main motivation why you usually move to the cloud, because the functionality you get, the access you get to services, that there's no way you could ever get them on-prem. I mean, I think that's usually, or that should usually be then that's where you get the most benefit of the cloud. If you really start using these services, if you really, you can say you can have more data, it's scalable. So that's where you get the real benefits.
Yeah, but you have to keep in mind it's not cheap. Like Eka said here, like she mentioned BigQuery.
Yeah.
Compute for BigQuery. This, if you have a lot of data and you make queries or do queries that use a lot of data,
but
get expensive.
It was also but also, I mean, it would have also not been cheap if you bought the hardware yourself, and also you don't know how much you need. I mean, that's the OPEX CAPEX thing, and also I think what people often underestimate, the amount of, like, people cost money as well, right? I mean, if you spend, I remember how much, like also like back when this space is full, for example, like how much time you spend on cleaning up your disk, kind of, or like or like maybe if optimizing queries, maybe just to and if someone spends a month on optimizing a query, which you could solve with additional hardware, what's the trade-off? I mean, I think that's often what gets forgotten, that people work with.
I can see that, because like I had instances where I need more hardware, so here's the form for the invest, and then once this is signed by 2 steps above, then it goes to IT. It takes 2-3 months till the hardware is here, and 4 weeks until somebody has time to actually install it. So
and I mean, also, what do you do? So also, if you have wait times, right? You want to do this. Actually, someone wants this, and then you wait 3 months to. do it.
It
So
makes no sense.
I just think that the main benefits from cloud, they don't come because it's not cost saving why you should move to the cloud. There might be cases, but that's not the main benefit. If that's your main driver.
Yeah, the agility basically is the big thing, right?
Yeah.
There's a question from Rupesh here. Please tell me the difference between data lake and data warehouse. That's true. We were talking about this, but we never really defined it. So,
Sure. So essentially, as I said, a data warehouse is an analytical system, a central repository where you store data from various sources, especially structured data. But it is also a tool where you can query your data. So it natively typically supports SQL. And a data warehouse is especially a good choice if you want to analyze lots of structured data, such as I mentioned, financial transactional data. If you want to do descriptive analytics on the data, such as generating regular reports or financial reports. And it's data warehouses are also good when you have the requirement that your SQL queries should be of very high performance and low latency. That's what data warehouses are especially quite good at, so to say. Now, a data lake rised as an alternative to handle big data and to deal with a few pain points of traditional data warehouses. So it's a data lake essentially also is a central repository, but it can store actually any type of data. So the key idea is that we now replace a database system with a low-cost object-based storage, such as a cloud storage, as in AWS S3, on GCP, it's Google Cloud Storage. So our data is now available as a whole object in any file format, be it JSON, CSV, or be it even JPEG or MP3 audio and video files and so on. So instead of a data format, which is prescribed by the data warehouse or basically the native database format. So the key difference actually that I want to point out is that a data lake is just a place actually to store your data. So you actually need a separate process to handle the processing of data. While a data warehouse, seen as a product or application, can already process data natively using SQL. However, as I mentioned in the beginning, data lakes offer way more flexibility to data processing because now we have this decoupling between storage and compute, and we can use any processing frameworks we like to process our data that resides in the data lake. So we can use something like Apache Hadoop, we can use something like Apache Spark, or we can even use something SQL-based like Presto or Trino, which is the case for Amazon Athena. So we are not dependent on the native tools of the data warehouse, but we can use any data processing framework basically we would like. So, yeah.
And I would say also one key difference also in the data warehouse, I mean, you transform before you store, right? And then you have the data fixed in a way, that's the data. And in the data lake, you put it in the raw and you transform when you pull it out, right? I think that's the other key difference in terms of use case.
Exactly. Yeah.
Also to what Kristine just mentioned is the difference between schema and read, which is the case for data lakes, and schema and write, which is the case for data warehouses, where in data warehouses, you have to define the schema basically before you write into the data warehouse. So it has to be structured. That's why it's actually called data warehouse. The term warehouse implies that your data has a specific structure or well-defined schema. And in a data lake, you can simply dump your data. This is a lot of flexibility, but as I mentioned, this can be abused.
I mean, it moves the responsibility somewhere else, right? It's in the end, you never get rid of complexity. It's just where you put it.
Yeah, where you take care of it. That's true. That's it. True. That's it. But that whole topic leads into a question here. why analytics platform backed data lakes, by data lakes? So an analytics platform with a data lake, why would you do this? What's the big move here?
Yes.
Why would
So
do this?
one big point or limitation of data warehouses is that they are essentially optimized for structured data, as I mentioned in the beginning. But what about unstructured data such as audio files, video files? What about semi-structured data such as CSV or JSON? I know data warehouses today support those type of data formats, but they are essentially not made for that in the first place, not optimized for that. And with data warehouses, you are, to a high degree, you are restricted to descriptive analytics. But what if you want to build machine learning models? And machine learning, especially, it obviously depends on the model that you use and what you want to find out. They do better with data that is essentially unstructured or semi-structured. And if you use data warehouses, you are limited. It's quite difficult to perform those type of analytics, these predictive analytics or even prescriptive analytics. And with data lakes, a whole new world actually opens for you, because you have this flexibility that if you ever would like in the future to perform more advanced types of analytics, you have the data essentially stored in a data lake, and then you can consume that data with different kind of tools to perform different types of analytics, so to say. So I think that's a big bonus.
What's the difference? Sorry, but I don't have a data. What's the difference between prescriptive and predictive?
So in predictive analytics, you actually try to predict something. For example, the stock price of a Aktie, stock.
Stock, yeah.
And yes, prescriptive analytics is basically, it's a lot, but one component can be to that the result of the analysis, so to say, prescribes a decision that should be made. For example, like you should do this and that. I don't have a good example right now.
One example, that's something I was working on before, was for prescriptive, is you have a machine that you want to monitor, that you want to figure out if something goes wrong. And once something goes wrong, the analytics already gives you a recommendation what to do. So it prescribes you the solution for it.
Okay.
Right? So it says, okay, here, now replace pump.
Yeah, okay.
Servo pump X or something.
Okay. Whereas predictive would be, at some point in the future, you will likely have to replace these and these pumps. That would be.
Yeah, something will happen most likely in the future.
Okay. Sorry for that.
It is a good question. It's a very good question. A lot of people don't know the difference for it, so that's a good thing to ask. It's also what you mentioned. The structure of data warehouses is different than or is not optimal for machine learning. I'm guessing it's also because it's for a different use case, right? You want to use your warehouse for analytics use cases where you create BI reports or have different use cases than running machine learning algorithms and
Yes, I agree.
Doing predictive analytics.
Yeah,
that's okay. So that's the case with a data lake backed warehouse. You can basically do both, right? Or almost do both.
Yes, I mean, you could still use a data warehouse, so to say, for your structured data, and you might also collect, as I mentioned, semi-structured data from I don't know, clickstream data, for example, or social media data, and then dump it into your data lake, archive it, or in the future you might have these data scientists that joined your company, and now you might be able to, I don't know, explore this data and also explore new data use cases to generate new insights, so to say. So with the data lake, you can still use a data warehouses, you can still build machine learning models and so on. So basically, as I said, you have way more flexibility. That's all. But what's interesting, a data warehouse is actually a bug term. There's no clear-cut definition. For example, when Airbnb talks about data warehousing, I found out that they actually talk about their data warehouse. In that case, would be S3, which is an object storage, and they would use something like a query engine like Presto or Trino on Amazon EMR, and that would be their data warehousing solution. So different companies actually use these terms a little bit differently, so to say. That's.
But I would argue, but I mean, I would argue that the tool that, I mean, concepts and tools are different things in a way. I mean, data lake does not equals S3 necessarily.
No, of course not.
I mean, in theory, you could use Postgres, create one JSON column, whatever, and put your JSON in it. I mean, and store all your JSON in a. I mean, that's far-fetched maybe a little bit, but I think it's not necessarily always in the end, it's the concept also, right? Not only the concrete technology.
Yeah, I think so.
Yeah.
It fits good to a question here, and I think we were because we are talking about formats, right? Objectively, how many companies use data lakes to store audio and video files? So if people think about file storage, many people think it's like video files, audio files, PDFs or stuff, right? But most of the time, did Eka write this? Didn't she also write this here? Like most of the time, it's predominantly tabular data, or CSV or JSON data, right? Very often.
I mean, there's a lot of companies that do that. I mean, Databricks, for example, has this concept of lake houses. So essentially, it's the best of both worlds. But you still use a object storage under the hood, but you treat your data lake as if it were a data warehouse, as if it was, as if your data would be in a relational form, although your data actually resides in S3, in CSV or JSON and so on. And I mean, there's even more to that. I mean, they use a different tabular data format. In that case, it would be Delta Lake. There are other tabular data formats such as Apache Iceberg, Apache Hudi, and so on. And they have a lot of companies that actually use the data lake to store semi-structured data, not only images, videos, audios, and it works quite well. So, yeah.
But like with now I have the experts here. So a lot of people talk about Databricks and Lakehouse and so on, and Delta Lake, right? But when you look into under the hood, you look into the files that it stores Parquet files. So it's not really a big deal. And when then you look into AWS, isn't this exactly the same thing that you do with Redshift Spectrum? Like,
I mean, kind of, yes. It's good if you store your data in Parquet format instead of CSV or JSON, because data gets stored column-wise instead of row-wise, as in relational databases, which is more efficient for analytics. And the difference now, for example, at Databricks, they have this tabular data format, which is Delta Lake. And yes, data is stored in Parquet format, but essentially it has a few more features. They have this concept. They've brought this concept of transactions now in the data lake. So you have a transaction log, you have these manifest files, and they essentially enable your data lake to be ACID compliant, such as MySQL or PostgreSQL. So you have this concept of transactions, which is quite powerful. It also enables you to do time traveling because this transaction log basically stores all of the operations that have been done, so to say, to this point, and you can basically jump back as if you would be time traveling. And there are even more features. So actually, there's a difference. But even in S3, you could, Databricks to a high degree also is used in AWS. Even in AWS, you don't have to use Delta Lake to have this lakehouse feature, so to say. You could also use, as I mentioned, Apache Iceberg or Apache Hudi, or even Lake Formation now supports this feature, govern tables, which is essentially also a tabular data format that stores your data a little bit differently, so to say. Yeah. That was a lot, sorry.
No, all good. So there is a difference. It's always when you look into the details, it's different. But I think, yeah, a lot of people only see it's like the hype behind it, but you can do a lot of stuff on AWS as well. It's not like
True.
It's not like this is the one thing and like, yeah.
There's never the one thing, right? It's
all right. So we had on our agenda, we have two more topics here. E-scooter use case. I think that would be really cool to talk about that. And then let's look at Q&A. I'm taking questions while we talk here, so most likely we don't have that much. So, Arber, you wanted to show us a use case for e-scooters.
Yes. Let me share my screen.
Yep.
Let's see. So you can see this diagram, right?
Not right now. Let me see.
Oh, you don't?
I can't, but now I can edit
it's
it.
slow.
I think I need to. Yeah, no, we saw it.
Okay.
I needed
So
to add it actually to the screen.
So basically, this is also what Data Toolkit currently supports. It's just simulating a kind of real-life use case. And all the way to the left, we have our data source, which is essentially some scooter data. It's a fake company called Scoofy. And this company publishes data on a daily basis in this S3 bucket. And what we wanted to do, or what we want to do, is basically ingest this scooter data into our data lake, do some transformations on it, and basically analyze it and analyze it via SQL using Athena, and finally also visualize it using a BI tool, for example, QuickSight. But in our case, we chose Superset. And this is a, let's say, lightweight data lake example. This is a batch processing pipeline, because in here we have this JSON data, which I will show in a minute. And this data gets ingested into our data lake by a Lambda function daily, incrementally actually. So it will only ingest new updates, so to say. And the storage layer is basically our data lake, which is S3. And for those that haven't worked with data lakes, a typical design pattern is to divide your data lake into different zones or buckets. Zones or levels, sorry. In S3, those would be called buckets or levels. And for example, you have this, in this case, we have three zones: raw, stage, and curated. And you don't have to use this naming convention. I've seen everything used in here. For example, Databricks calls it the Medallion architecture, and there it is called bronze, silver, and gold. So every company has a different naming convention. Basically, what we do, we store our raw data as it is in its original format in the raw zone, which is a bucket. We then use Glue. Glue is a serverless Apache Spark platform by AWS, for those that don't know. We use Glue, we write PySpark code, Spark code in Python to transform that data into Parquet format, because Parquet is essentially a little bit more analytics friendly, so to say. It's a little bit more efficient to perform analytics. We then transform that data into Parquet and store it into our stage bucket. What we also implemented in our data toolkit is dbt, so to say. For those that don't know, dbt allows you to do ELT with SQL. So you can transform your data using SQL statements. dbt actually only stores these SQL statements, but they still have to be triggered or executed by a query engine. And in our case, that would be Athena. If you have a data warehouse, that would be your data warehouse, for example. But in our case, we set up a serverless data lake and used Athena. And what we do here is actually let's call it, we create our data marts, which is essentially we create, we transform our data in a way that's basically pre-aggregated. So we already do some basic aggregations on the data, do some statistical calculations, so that our analysts basically have to do less work, so that they already have some data with some provided insights, so to say. In data modeling, it's also called to provide fact tables. So yes. Now I know there's some other components. As a data catalog, for those that don't know, a data catalog is essentially a central repository where you store metadata about your actual data in the data lake. So metadata will be where your data actually resides in the data lake, and what data format it resides in the data lake, what schema it has, for example, which columns have which data types, and so on. And what the data catalog enables us is two things, actually. On the one side, it enables applications and users to find data more efficiently, because otherwise you would have to go to S3 and look up all these data files. But the data catalog is a repository that stores that data in form of tables, so to say, so that we can actually query that data using this table abstraction. So that's quite handy.
It's not like you, because a lot of people misunderstand that you don't store the data in the catalog. The catalog is just the, how do you say this? The description of the data.
I mean, it's like a catalog, like a shopping catalog or not. You have,
Yes.
This is the price, this is the color, this is this, and you don't expect the actual thing to be in the catalog. You expect that you can order it or that you can look up this metadata in the catalog to get the actual thing.
Yeah.
Yes.
So I think the name is actually quite. But Arber, this is so, and this is now the tool. No, this was the example, but you have this implemented with this toolkit.
We have implemented this with the toolkit, right? I can show it in a minute. What I also want to mention is that you can use infrastructure as code to basically have this whole resources and configuration and infrastructure as code, as mentioned. You can use Terraform for that, or you can use, as in our case, AWS CDK to do that, which has some pretty nice benefits.
Yeah, this is something that's where I'm where I have the feeling, but maybe that the data world didn't yet jump completely on this infrastructure as code and automation. Andreas, I don't know what's your. I mean, I come from like a DevOps background, so I'm not sure. But
I think it's coming more and more. It needs a lot of expertise to set that up, to run everything as infrastructure as code. And it's not like you, yeah. Otherwise, you could set individual tools up, and I think a novice can also do that, or somebody not really.
But I mean, maybe that's good siege. That's why we have the cool toolkit in a way, right? Because it's not. I personally would say it's not that the hard part is the configuration, I think, in a lot of cases. But this is no matter where you do it, it's hard to get it right if you don't know.
Yeah. And that's also what I mean is exactly as you said, the configuration, the actual setup is the difficult part. But doing this with something like CDK might be difficult for somebody who's not an expert in it, right?
That's
People are
my
struggling.
concern,
That's
yeah.
where you're coming in.
Yeah,
Let's be honest. You're the experts. You can give people a hand. But for somebody like me who's not a super expert in AWS, and a person sees, okay, CDK, and like, how do I set everything? I was like, most likely a daunting task to do. Right.
Yeah, but I think that's exactly the reason why we have this toolkit, right? Because I think it's kind of the blueprint, like it sets you up a complete infrastructure from scratch, using infrastructure as code with all the services, with like sensible default configurations, and then you can go from there. And I think once you have this default setup and you know, okay, maybe I now need to change some configuration, okay, then you know, okay, this is code, you change it, you deploy it, easy. Whereas I can see this, if you have no idea, it's like, how do I even, get started?
Let's talk about that toolkit. So this is the example for the e-scooters use case. So on the left you have the e-scooter basically delivering the data. Then you have your ingestion, the storage, and the orchestration part that you explained, Arber, and then you have the consumption side here with Athena and Superset or
yes.
How's it called on AWS?
QuickSight.
QuickSight. Yeah, it could be.
Yes.
So, and now let's talk about how to set this up easily out of the box, like with a few clicks or.
You don't click. Infrastructure is code. You don't click.
I'm the guy. I'm very user interface oriented. So for me, it's always clicks.
I think that's maybe one of because there's this question, right? What's the concept of infrastructure as code? You don't put it quite simply. You don't click.
That's true.
Never touch your mouse.
So yes, where do I start? Basically, this data toolkit, we will open source it shortly. It will be available on GitHub. It's already there. We just have to make it public. And there, as mentioned, we have this whole infrastructure as code, as a CDK application. So all you have to do is actually just read the documentation. We documented everything. But basically, you have to have Python on your machine because we use CDK with Python. And then you basically just have to execute our make files. Well, you also need a AWS account, so to say, and credentials. And then what you can do is basically deploy this setup I just showed into your AWS environment and play with it. Play with it or even customize it to your needs using different data sources. There's generic glue jobs, which basically load your data from a source bucket, write it into a destination bucket, and you can customize these glue jobs, which essentially are just Spark code or scripts, whatever. So all you have to do is actually say CDK deploy. It takes a few minutes, and that environment is essentially then deployed into the environment.
Can you show? Sorry, Kristine.
I just want to say, basically, I think it saves you 1 hour of clicking around in the console. And then also after this, it's also, I mean, it's infrastructure as code also. I mean, you have everything in code, right? I mean, you have an audit trail, you make changes in a controlled, repeatable manner. So you don't have the issue that someone goes into the console, clicks someone, change some parameters, something breaks, no one knows what happens. So it's all more controlled and reliable. So I think that's kind of the benefits. And
and repeatable. That's
exactly.
you mentioned that it's always going to be the same.
Yeah,
can you show us? I'm sorry.
No, I just want to say also across different environments, right? I mean, you roll it out to one, and basically you can change the parameters. You roll it out somewhere else. It's the same. It's there's not that you don't run into the danger of having a diff.
True. Arber, can you show us I
can show
diagram of it or a bit about it?
If you want, I can show you the AWS console, and then we can look at the data, for example, and at these different services like S3 and Glue. Or
Yep.
is that's what you want to do?
I don't know. I thought we can do that. I thought you also had because in my emails I had that overview of the toolkit, how everything is set up, like that diagram here, just in a different manner.
There's also a let's see. I mean, basically, there's also this diagram. What's happening here?
It's on the screen.
Yes, which basically shows what the goal is, so to say. Wait, let's show this diagram basically. As I mentioned, data lakes are quite flexible, and what we want to do with Data Toolkit is basically provide developers with a toolkit. And whoops, sorry. By that I mean basically that at our clients we saw that data lake architectures reveals similar patterns with regards to the components that I use and how to handle different data workflows. For example, I showed you this Scooter example, which is a batch processing pipeline, but as those JSON files were actually treated as IoT data, you could also implement it as a streaming scenario, and that's what we actually want to do next, and integrate it into our data toolkit to also have streaming pipelines which are ingested into our data lake and basically then performed analysis on that. So what we want to implement, what's missing is actually, for example, lake formation. Lake formation is a service that basically secures your data lake or the access control. You can fine granularly control who or what application should have access to what data in your data lake, which is quite handy, quite powerful. Currently, we're doing this governance with IAM policies, which works. But as data grows, as data consumers, as we have more data consumers, so to say, more people working on our platform, it will be way more handy to have a service for that instead of doing everything via policies.
Yeah.
So, yes. And yeah, on the consumption side, as I mentioned, you have all these different options. You're not limited to something SQL-based like Athena. You can build machine learning models. You can still use a data warehouses such as Redshift or Snowflake. You can use any BI tool such as QuickSight. In our case, we will use Superset because it's open source, it's free. It's quite a cool tool, so to say. And yes, actually, I could have shown you the console, but maybe that would be a little overkill. I don't know.
The console of what do you mean?
This Scooter scenario showing the data set, how it's then transformed to Parquet, basically those different steps. No, I feel you. I think it might be a little overkill.
I'm afraid this could get very, very difficult. Can you show us, like, because there are questions here, like can you provide the GitHub for this? You mentioned it's not finished right now, right? You're working on this.
It's actually what's only missing is a superset. We are setting this up, and then we will make this project open source, because we initially hosted the project in our own GitLab instance, and we used a Jira ticketing system, and now we are migrating it to GitHub and use basically GitHub's issues to as a ticketing system, so to say. So yes, it's almost finished, so to say, and then we hope that the community is open to also maybe contribute to this project, so to say.
Yeah. There's There was a question. I want to
Mhm.
talk about this quickly. Like, can you, because infrastructure as a code, can you show us something from the GitHub, like so that people maybe get a visual feel of how does such a configuration look like? You know what I mean?
And maybe you can
I know
quickly show the repository. Just brief
Sure.
Yeah,
glance into the
how
repository. You know, just
how
show the
would that-
code.
not to go. I'm going to remove that for a sec. Like not every detail, but like this is how something actually looks in CDK to set this up. Because
Yes.
I guess a lot of people don't know what that means actually.
True. So basically, this is our repository, and we have one use case, which is this goofy example. This is represented under this batch folder. When we have something like a streaming scenario, it would be a new folder basically. And in this folder, here's our CDK application. And the CDK application is basically, if you execute it, it basically generates CloudFormation templates that are then consumed by CloudFormation.
CloudFormation, maybe you need to, it's basically the tool in AWS that deploys then these changes for you. Basically, it's the infrastructure as code, the raw infrastructure as code tool from AWS, and CDK is just glorified wrapper is wrong, but basically it eases the usage of CloudFormation. So it makes it easier to use CloudFormation. It has a whole other lots of benefits. I think would be too deep now, but basically CloudFormation is the infrastructure as code tool in native to AWS, which then deploys your changes. So you configure what you want, and then CloudFormation takes care of deploying this to the cloud. It's your basically CloudFormation is what you otherwise would do manually by clicking.
Yes. And what we also set up is initially what everyone should do is set up a CI/CD pipeline where linting is performed, tests are run, because we actually completely tested our infrastructure, so to say, so that it's, let's say, quite reliable. So there's trust in it. And currently it's in GitLab, as I said. We are migrating it to GitHub, so we will make use of GitHub Actions to do that. And it's basically a standard CI/CD pipeline where you first install the required packages, you run static tests, integration tests, and then you basically deploy your infrastructure, which in this case is a CDK deploy command, which just references our CDK stacks. I know that's a lot of terms. It's basically where you describe your resources, your S3 buckets, your glue configuration, your DBT configuration, your lambdas, and so on. You basically just say CDK deploy, and where you want to deploy it, obviously, in what AWS account, and then it's magic, so to say.
Yeah. Okay. Yes. I think that
reliable
that makes
magic.
It a bit, yeah.
Reliable magic.
True.
I think that makes it a bit clearer on how this actually works. And it's
and
a really,
this,
really cool way.
Just want to say this also ties back what Arber said in the beginning in his introduction about software best practices, right? This is really, you apply like best practice or the practices to this as well. So as you said, also as you can test your infrastructure, you can actually make sure that your infrastructure behaves the way you want it to behave, and also does so the next time and the next time and the next time. And if you break it by accident, you have tests that tell you broke it. So I think that's one of the other main benefits, really, also of using CDK, for example, because you can write it.
Okay. Yeah. Okay. Let's finish this.
Sure.
I have a few questions from the chat, and then I think once this is out, I'm guessing you'd let me know so I can share it with the people, and I can put it in the description here. So if somebody looks at this in a month or so, I don't want to put pressure on you when this is finished. So then it's going to be in the description.
For sure. Maybe one thing I want to point out, this toolkit so far is completely serverless, so you don't have to pay anything upfront, which is quite nice. And it's modular in the case you can adapt it to your use case. And I think you can also learn a lot from it if you have never worked with data lakes or analytics on data lakes. So I think it's quite handy.
Ruas here, Peter says
Hello.
here, no, not hello, this
Hello.
one here. Yeah, hello, hello, Peter. I want to say here, he says, thank you, much clearer now. Because that was the question here about infrastructure as code. I know that's another one here. If that's first one, what's the concept of infrastructure as code, and the second one here, that doesn't work on premises.
Some people say Ansible is infrastructure as code, so that works.
I don't know. So this is typically something for the cloud.
Not necessarily. I mean, I think the term when it was coined, then there was also for the cloud. But in the end, you have you have Chef, you have Puppet, you have Ansible. So you have a lot of actually tooling that deploys infrastructure on premise. So, but I think usually most people move to the cloud anyway. I mean, it's.
So there are ways of doing it.
Of course.
But, I mean, not with CloudFormation and CDK. I mean, that's native to AWS. I'm actually not sure if Terraform has some.
I think actually.
I'm not sure. Also, in the whole Kubernetes ecosystem, there's a lot of automation. But yeah, if you talk about CloudFormation, CDK, I mean, it's assuming that most people move to the cloud. I think infrastructure as code, if you start from scratch, is usually applied to the cloud.
Let's make a cut here, because the other questions, if you have time and if you've maybe you can look in YouTube and answer one or two other questions.
Sure.
I think it doesn't make sense to add this here right now. So yeah, for me that was very interesting. It's like every time I talk to the specialist, I learn something new. I hope everybody else learned something new here. Thank you, Kristine. Thanks, Arber.
Yeah, thanks a lot for having us.
Thanks from my side also, Andreas. I really appreciate your work, because I remember when I started my data engineering journey, I was so overwhelmed with all the tooling, all those words and concepts. It's quite nice to have people like you that do something for the community to take the pressure away from you and basically make all the stuff available for free. So thank you for that.
Yeah, that's overwhelming. It's very, very good. Okay, so thanks. Let me know how it goes with the toolkit.
Yes.
And all the best. Thank you for being here.
Thanks a lot.
Let's make a cut. I'm going to end the broadcast now. Bye, everybody. Have a good one.
Bye.